Okay, greetings. This is to be a video lecture covering the notes for the first section of notes on categorical logic and deductive reasoning. So in a standard logic course, you would spend a good deal of time on deductive reasoning, and you would probably do something like categorical logic and truth functional logic, maybe even predicate logic, etc., and various forms of deductive logic. And I used to include some of that even in this course on critical thinking, but I have moved away from that in this course. And so the only extended treatment of deductive logic systemically is going to be on categorical syllogisms, and beginning with categorical claims and then moving on to categorical syllogisms, because I like you to see the sort of objectivity that arises from categorical logic and logic in general. And so it's not like, well, maybe that argument's valid for you, but it's not valid for me. Well, that's not really the way validity works, and hopefully you'll see that as we move along. So I have two lectures here, two sets of lecture notes rather. One dealing basically just introducing the notion of categorical claims and their relationships to one another. And then the second set is actually looking at categorical syllogisms and how to evaluate them for validity. So that's the plan. Now, truth be told, I've done this lecture twice already, and the first time the audio came out terrible, and the second time I used the wrong notes. So maybe the third time's the charm. You'll have to let me know. Now, I'm not going to do a PowerPoint presentation, and you're probably thinking, oh, thank God. Yeah, well, I'm not doing a PowerPoint presentation, but well, why is this doing this? Share my screen. Sure, why not? Okay. So I'm not doing a PowerPoint presentation because I'm basically going to just walk you through the notes that I have. I think that they're organized fine, and my PowerPoints tend to just be a representation of the notes themselves. And so this might be helpful. Then plus, if as you're reviewing the notes, maybe you don't have any trouble at all, and so you don't need to look at this video, or maybe there's one or two points you're not quite clear on, well, you'll be able to scroll through this video to the place where I talk about that section of the notes. Okay, that's the plan at least. So this is my somewhat lame web page. This is my somewhat lame web page that's our syllabus, and this takes us to the calendar, which has links to our lecture notes, as you know. And I'm moving along now to Deductive Arguments 1, Categorical Logic. So we're going to talk about categorical claims, standard form categorical claims. We're going to be talking about universal and particular, affirmative and negative, unit classes, Venn diagrams, square of opposition, hypothetical, square of opposition, existential, distributions, logical relations, and fallacious reasoning regarding contraries and contradictions. Doesn't this sound exciting? Hopefully you are. All right, so this is sort of a silly little quote where I'm referencing Moliere's character. It says, I was shocked to discover I've been speaking prose my entire life. Well, you've probably been making propositions and categorical propositions your entire life at that. So that's the point of that little joke. But let's move on. Formal logic and categorical claims. So the classical study of deduction has also been called the Aristotelian study of deduction. And it was so named because it was named after the Greek philosopher Aristotle. Aristotle and generations of logicians afterwards confined themselves primarily to the study of certain kinds of statements, specifically categorical statements, and the logical relationships among these statements, and arguments that were comprised entirely of these kinds of statements. Aristotle and later writers found that mentally moving from one group of statements to another certain conclusion, when arranged in a particular way, was good, correct, and logical. But certain mental movements from different arrangements of statements was not good, not correct, and not logical. So they noticed patterns building up, and the relationship between those patterns. And they formalize those into rules. And these are the rules that consist of categorical syllogisms that we will be studying a little bit later on. Now, before we do that, we have to look first at what is a categorical claim or a statement or a proposition. I'm going to use those words interchangeably here. Well, they are claims that are about classes of things, or sets or categories, right? Hence categorical claim. A class or a collection of objects that have been specified by a common characteristic, right? So it might be talking about whales or cats or breakfast cereals or something like this. There are various ways in which one class might be related to another class. If every member of one class is also a member of the second class, the first class is said to be included or contained in the second class. For instance, the class of blue Toyotas is included in the class of cars. However, if only some members of the first class are included in the second class, the first class is said to be partially contained in the second. For example, the class of blue Toyotas is partially contained in the class of scratched cars. That is, some blue Toyotas are scratched, but others are not. And so they wouldn't be members of that set. And there are some pairs of sets that have no members in common whatsoever. These are disjoint sets, such as the set of all Toyotas and the set of melons. Right? So no Toyota is a melon, and no melon is a Toyota. Under circumstances, you might get a Toyota that's a lemon, but that's another story. All right, let me try it this way. Yay. Categorical forms and categorical claims. Oh, I'm sorry. Standard form categorical claims. All right. So in ordinary informal logic, we can express categorical claims in all sorts of different ways, right? I might say all men are mortal. That's fine. I might say every man is a mortal, or every man is a mortal thing, or each man is mortal. Right? All of those claims are categorical claims, and in fact, all of them express pretty much the same categorical proposition. But only one of those is in, actually, now that I look at it, none of those are in standard form. Now, why are they not in standard form? Well, for two reasons, principally. One, standard form categorical claims have to be one of the four listed here, where I'm saying all blank are blank, or no blank are blank, or some blank are blank, or some blank are not blank. We'll talk more about this in a moment, right? But in other words, every is not a word that appears in a standard form categorical statement. Likewise, each is not a word that appears in a standard form categorical statement. How do I know that? Look at the list. There's not the word every does not appear, the word each does not appear, etc. So these are the only words you're allowed to use if you're putting a categorical claim into standard form. Now, are they the only words you're allowed to use if you're expressing a categorical statement? No, right? As I mentioned, all of those are categorical statements. They're perfectly fine. There's nothing wrong with them. And in ordinary language, you're getting your ideas across just fine. But when you're doing standard form categorical logic, you have to conform yourself to one of these four forms. All right, so I'm talking about all blank are blank. What goes in the blank? What goes in the blank has to be a plural noun or a plural noun phrase, right? So for instance, all men are mortal is not a standard form categorical claim. Why? Well, because mortal is an adjective. Mortal is not a noun phrase, right? So if I said all men are mortal things, now we're fine. Now we have a noun phrase, mortal things. And so we have all, plural noun, are, plural noun phrase. That's fine. Or all men are mortal objects, or something like that. Oh, that would be fine. But if I said all men are mortal, and I ask you, is that a standard form categorical claim? The correct answer is no, right? And why is that? Because the predicate of that sentence is not a plural noun and it's not a plural noun phrase, it's an adjective, right? Likewise, if I said, no cats are friendly, that's not a standard form categorical claim. Friendly, again, is an adjective. But if I said, no cats are friendly things, right, that would be fine. Or if I said, I don't know, all bananas are fruit, all right, that's fine. Fruit is a plural noun, right? So those would be okay. Right? All right, so reading from the notes here, note that each of these categorical claims relates one category in whole or in part, as indicated by the subject term, I have A's there, to another category indicated by the predicate term, B's, either affirmatively or negatively. Note further that the verb in a standard form categorical claim is always are, okay? And that both the subject and the predicate of a standard form categorical claim must be a plural noun or a plural noun phrase. So pop quiz, why is the claim no cats are friendly not a standard form categorical claim? Well, I already gave that one away, didn't I? It's because friendly is an adjective and it's not a plural noun or plural noun phrase. Right? All right, so I think I move on to, let's try this. There we go. Hold on. I think we're on to number 3 now. Yes, okay. So categorical claims have a quantifier, or they have a quality that we call the quantity of the claim, right? And they come in 2 varieties, universal and particular. If the categorical claim makes a claim about an entire subject class, then it is a universal categorical claim. So for instance, all toys, no fish, all bugs, no people from Georgia, okay? Each of those begins to say something that is true of each and every member of the subject class. Hence, it's a universal claim, is making a claim that is categorical without exception to any member of the case, of the class. If the categorical claim makes a claim about one or more members of the subject class, but not every member of the subject class, then this is called a particular categorical claim. So if I said some eggs or some men or some Lutherans, right? Well, I'm not talking about each and every member of the set. I'm merely saying some subset of the entire universe, right? Now, note that all categorical claims have either are universal or particular. Also notice something else about the word some. In categorical logic, the word some has a technical meaning, and it means at least one. So when I say some eggs are, whatever, I'm committed to the idea that there is at least one egg, which is, right? Maybe more, maybe lots more, maybe all the eggs are, but that's not what I'm saying in this claim. All I'm saying is there is at least one egg such that, right? There is, so some eggs are delicious breakfast items. I had to get a plural noun phrase in there, okay? Maybe all eggs are delicious breakfast items, but what I'm committed to in that sentence is not all. What I'm committed to in that sentence is there is at least one egg, which is a delicious breakfast item, okay? But in addition to quantity, categorical claims have a quality, and the quality is either affirmative or negative, coming from the Latin affirmo or nego, which is I affirm or I deny. If I'm affirming, then I'm saying something is the case, and if I'm denying, I'm saying something is not the case. So an affirmative claim asserts the existence of a relationship between the subject and the predicate term, whereas a negative categorical claim denies a relationship between the subject and the predicate term. So notice when I say all A's are B's, I'm asserting there is a relationship between A's and B's. Or when I say some A's are B's, again, I'm asserting a relationship between the two classes. But when I say no A's are B's, I'm denying a certain relationship between these two classes. Likewise, when I say some A's are not B's, again, I'm denying. So now we have our four categorical claims. All A are B, all B are, all A are C. Let's try that again. All A's are B's, all no A's are B's, some A's are B's, and some A's are not B's. Those are our four claims. Two are universal, ding, ding, ding. Two are particular, ding, ding, ding. Two are affirmative, dot, dot, dot. Two are negative, dot, dot, dot. Okay. Number one is a universal affirmative about the two classes, and we refer to it as an A claim. Affirmo, we use the A, it's an A claim. Number two is a negative about a universal about the two categories, and we call that an E claim, again from nego, right? Some A RB is a affirmative particular about the two claim, and we call that an I claim, coming from affirmo, which is the I from affirmo. And then the last one, some A are not B, is a negative particular, and that is called an O claim. So these four claims are accordingly A, E, I, and O. Okay. So again, they are written systematically this way. Oh, by the way, I go back and forth. I'd have to clean up my notes even more to fix this. But here now I've switched to S and P. That's a pretty standard way of rendering these S and P, because the idea is S stands for subject class and P stands for predicate class. And so in an A claim, all SRP, every member of the subject class is a member of the predicate class, or no SRP, no member of the subject class is a member of the predicate class. Some SRP, there is at least one member of the subject class, which is a member of the predicate class, and some SR not P, there is at least one member of the subject class, which is not a member of the predicate class, right? Again, if you're any English sentence you give me, if it's a standard, if it's a categorical claim, and I'm asking you to translate it into a standard form categorical claim, you've got to pick one of these, okay? And what goes in the blanks? Well, we already said what goes in the blanks is plural nouns and plural noun clauses. Now, what about unit classes? What about when I say that Socrates is a man, right? Well, there's only one thing that is Socrates. And so how do you get a plural noun or a plural noun phrase? And how do you express that? Well, unit classes, categorical claims concerning unit classes are considered to be universals because there's only one. So you're talking about each and every member of the set. There only happens to be one member of the set, but you're talking about each and every member of the set. So we would render something like Socrates is a man would be all things identical with Socrates are things identical with men. Or I guess I could just say are men, right? All things identical with Socrates are men, right? And again, we're expressing the idea Socrates is a man, but we're expressing it in a standard form categorical claim. It's an A claim and it's A, right? If I said Socrates is not a chicken, I mean, the fowl, he wasn't a chicken in any sense, but I'm going to be literal here. Then I'm saying no thing identical with Socrates is a chicken. Are chickens. There we go. Now I'm not doing, I'd have to mark myself wrong on that one. So I'll do better this time. No things identical with Socrates are chickens. There we go. All right. Then we have a standard form categorical claim. It's a negative universal because I'm denying that Socrates is a member of the class of chickens. All right. I don't know. Strikes me as a little funny, but all right. Yeah, we did all of that already. So let me see, where are we? Yes, unit classes. Venn diagrams. So Venn diagrams. Because each categorical claim involves two categories, we need two circles in order to indicate the two categories, right? So we have this one on the left-hand side, and we have this one on the right-hand side, and they overlap. Now, assuming that this is S and that this is P, in other words, that the left-hand circle is the S circle, subject class, and the right-hand circle is the predicate class, right? Then we have our three regions. Number one would be anything which is a member of the subject class, but is not a member of the predicate class. How do I know that? Because it's inside the S circle, but it's not inside the P circle. In region 3, we have anything that is a member of the predicate class, but that is not a member of the subject class. How do I know? Because it's inside the predicate circle, but it's not inside the S, the subject circle. And what about this middle ground here? Well, notice anything that's found in this region is both inside the S circle and it's inside the P circle. So anything in here is both an S and a P, okay? It's a member of both classes. All right. So when it comes to Venn diagrams, there's basically three ideograms that are used to express ideas, right? The first is the circle that I already mentioned. And the circle indicates a class of things, right? If you only have one circle, you have one class of things. You have two circles, you have two classes of things. You might get 3, 4, 5, but not, we're only going to do 2 circles today. In the next lecture, we talk about 3 circles, but the circle indicates a class of things, right? And hence, that's why we need a plural noun or a plural noun phrase. Now, the second convention in Venn diagrams is shading. Here you have to be careful. Shading does not mean full. There are other ways of, other diagramming motifs where shading might mean full. That's not what they mean in Venn diagrams. They mean exactly the opposite. Shading means empty. So when you see a shaded circle, what that's telling you is there are no members of this class, right? Or at least in this, within this area, okay? So for instance, the class of Yetis is an empty set. It's actually the empty set. There's only one empty set. There'd be nothing to distinguish 2 empty sets. So it's the empty set. There is no Yetis. Oh, I hope I'm not disappointing anyone. Well, you can take it up with me if you like. But but that's what this diagram is saying, and that's not up for grabs here. Why? How do I know it? Because it's shaded, okay? And then the third convention used by Venn diagrams is placing an X. Placing an X means there is at least one object in this region, right? There might be more, there might be lots, there might be hundreds, but the X indicates that there is at least one, right? Again, so what this is saying is there is at least one member of this class of things, right? So again, to review, the circle indicates the category, shading indicates that the category is empty, X indicates the category has membership. All right, so let's take our claims, right? We're going to take an A claim first, and the claim we're taking is all philosophers are idlers. Well, we have 2 classes, so we need our 2 circles, and here they are. Here's our subject class, philosophers. Here's our predicate class, idlers. Now, what is our statement saying? Our statement is saying that all philosophers are idlers. Well, that means that this class here, this region here, what would be in this region? If anything were in it at all, what would be in it? Something that is a philosopher, but is outside the idler circle. So something that's a philosopher and not an idler. But the statement says all philosophers are idlers. So what the statement is telling us is this region is empty. It has no membership. And of course, that's what that shading means, right? Now, if this is all we're given, this doesn't tell us whether there are any philosophers or whether there are any idlers. How do I know that? Well, there's no X, right? There's no X here, there's no X here. So this A claim, all philosophers are idlers, is simply telling us this region is empty and leaving it as an unanswered question whether these regions are empty or not, right? We don't know. All right. But now let's move on to the E claim. No philosophers are idlers. Well, that's saying the opposite of what the A claim is saying, of course, right? And that's saying that there is nothing in this middle region. If there were something in this middle region, what would it be? Well, it would be a member of the subject class, and it would be a member of the predicate class. But our statement is saying there ain't no such thing. There is nothing that is both a philosopher and an idler. Right? So it's telling us this region is empty. Again, is anything in this region? The diagram doesn't tell us. Is anything in this region? The diagram doesn't tell us. Right? It just tells us that this region is empty. Now let's move on to the I claim, the universal affirmative claim. Right? Some philosophers are idlers. Very good. So what does that mean? There is at least one thing that is both a member of the subject class and a member of the predicate class. Are there any philosophers that are not idlers? The diagram doesn't tell us. Are there any idlers that are not philosophers? The diagram doesn't tell us. The diagram only tells us what the statement tells us, and the statement merely asserts that there is at least one thing that is both a philosopher and an idler. And now the last of the four, no doubt you've seen this coming, or perhaps you have. Some philosophers are not idlers. Well, what is that telling you? That tells you that there's at least one thing that is a member of the philosopher set that is not a member. So it's outside of this circle. It's not an idler, right? And so that means this region has membership. Now, might there be philosophers who are idlers? We don't know. This region doesn't tell us. Might there be idlers that are not philosophers? Could be, we don't know. That's not what it is. All we know from this statement is that there is membership here, leaving as an open question whether there's any membership there. All right. So the figures 1 through 4 show the standard form categorical claims represented by Venn diagrams, which are graphic illustrations of what the claims say. In the diagram, the circles represent the classes named by the term. The shaded areas represent areas that are empty, and areas containing an X represent a region which contains at least one member. Right? So again, in an A claim, region 1 is shaded. In an E claim, region 2 is shaded. In an I claim, region 2 has membership, X. And in an O claim, region 1 has an X. And that's what these are right here. Okay. All right. And then I think I give you here, it's a suggestion that you go and try to, number one, translate them into standard form categorical claims. And then if you were to draw a diagram, what would the diagram look like? So you get a little bit of practice doing that. Okay. All right, unit classes and diagrams. The square of opposition. Categorical claims and the square of opposition, right? So a standard way of arranging the categorical claims is in a square, where each of the corners is you place one of the claims in each of the corners, right? So in a standard form categorical, try this again. In a standard one more time. In a standard square of opposition, the A claim goes into the upper left-hand corner. The E claim goes into the upper right-hand corner. I claim lower left, O claim lower right. Okay. So this is the standard square of opposition. But notice though, there's a difference between what's called the hypothetical view and the existential view of these universal claims. And I talked about this a little bit in the earlier lecture we did on language and ontology, and whether or not we should interpret universal claims as making a hypothetical claim. If anything is a unicorn, then it would be a horned animal. Or whether we understand it as carrying what's called existential import, so that if I said all of my children graduated with a 4.0 GPA, well, let's try that again. All of my children are college graduates. need my plural nouns. Well, it would be awfully odd if I told you all of my children are college graduates, but then I went on to say, oh, but I don't have any children, right? I mean, because you would assume that I do have children. So sometimes in ordinary, normal conversation, all A are B does not carry with it existential import. So when I say all unicorns are horned animals, a lot of people will accept that is true, even people who don't believe there exists any such thing as unicorns. On the other hand, if I said all of my kids are college graduates, you would think that's an odd claim for me to make if I don't actually have any children. So in ordinary conversation, sometimes universals carry with them existential import, and sometimes they don't. However, in standard categorical logic, we are quite explicit about that. And in a traditional modern understanding of universals, this is how it's always been done. No, I take that back. It's not always been done this way, but it's how we do it now. We presume the hypothetical interpretation. So when I say all S are P, this is understood in contemporary logic as only asserting this: if anything were an S, then it would also be a P, leaving open the question whether there is any such thing as an S. Likewise, when I say no SRP, I'm only saying this: if anything is an S, then it is not a P. So the way it's standardly understood, and let's just graph it out this way, is this way. There's no X here. I'm not claiming there's any X. I'm saying only if something's a P, a philosopher, then it's an idler. Likewise, there's no X here. I'm only saying if something's a philosopher, then it is not an idler. Right? And again, this is the standard way we understand, or the hypothetical way we understand universals in modern logic. Now, notice something else, though. In our square of opposition, the A claim, all S are P, is making the exact opposite claim of the O claim. The O claim says that some S are not P. And let's just take a look at the graphic on this. Here, the A claim is saying region 1 is empty, but the O claim is saying region 1 has membership. Well, they can't both be true. Either it's shaded or it's X'd, but it can't be both, right? They're saying exactly the opposite. So notice, if the A claim is true, the O claim must be false. And if the O claim is true, the A claim must be false. This is the logical relationship of contradiction. Contradiction, two statements are contradictory statements if they cannot both be true at the same time and they cannot both be false at the same time. So on this hypothetical square of opposition, the logical relationship of contradiction occurs between the A claim and the O claim. But notice, the same relationship occurs between the E claim and the I claim, right? Because the E claim is saying this region is empty, this middle region. The I claim is saying this region has membership. Well, either it's shaded or it's an X, but it can't be both. So if we know, where am I now? If we know the E claim is true, we know the I claim is false. Or if we know the I claim is true, we know the E claim is false. Again, the relationship of contradiction occurs between these two claims on the hypothetical square of opposition. They cannot both be true at the same time, and they cannot both be false at the same time. So I think that's what I'm saying here. And notice I have a little extra thing here, right? So the relationship of contradictions occurs between these two. Now, these are the only roads that exist on the square of opposition. In other words, there's a way of getting from knowledge about the E claim, I can get to knowledge about the I claim, right? Because there's a road here. And from knowledge about the A claim, I can get to knowledge about the O claim. So I can move back and forth between these two claims because there is a road, a relationship, a logical relationship. But this is the only logical relationship that occurs between the categorical claims on the hypothetical square of opposition. However, I'll use my fancy links because I went to all the trouble of making them. On the existential view of the square of opposition, that takes a different view. Now, this was the more standard way that that universal claims were interpreted in ancient and medieval times. So philosophers like Aristotle and ancient philosophers that followed him in this, and then medieval philosophers and logicians, they interpreted the A claim and the E claim not the way we've pictured above. They interpret these claims this way: all SRP, and there is at least one S. Or no SRP, and there is at least one S. So notice, this is a richer diagram, and it states more than the hypothetical depiction of the diagram, right? It's saying more. Well, on this interpretation, new logical relations appear in our square of opposition. I think I'll just scoot down to the square, but I talk about it here, but I'm not going to go over it. But notice that A claim, let's go back to the A claim for a moment. The A claim is claiming there's an X in this middle section on this interpretation, right? The existential interpretation. Well, that means if the A claim is true, the I claim must be true, because the A claim is saying everything the I claim says plus, right? There's that X in that middle section. Further, if the I claim is false, then the A claim must be false. If there isn't an X in that little section, then the A claim is false. So notice that is the relationship of implication. Two claims imply one another. If means that if the first one is true, second one must be true. But if the second one is false, the first one must be false, right? The same relationship of implication occurs between the E and the O claim. And why is that? Because the E claim is saying that there's an X in that region. Well, that's what the O claim says. The O claim says there's an X in that region too. So if the E claim is true, the O claim must be true. But if the O claim is false, the E claim must be false. Again, this is the relationship of implication. But notice something else. The A claim and the E claim cannot both be true at the same time. However, they can both be false at the same time. So this is not the relationship of contradiction. This is a different relationship called contrariety. We would say that these are not contradictions, these are contraries. What do I mean by that? They cannot both be true at the same time, but they can both be false at the same time. In other words, it cannot both be the case that there's an X in this middle section and this middle section is empty. Nor can it be the case that there's an X in this left-hand section and that this left-hand section is empty. They cannot both be true. Can they both be false? Yes, they could both be false. If this one isn't empty and there's an X here, and if this one isn't empty, there's an X there, then they're both false, right? There's a membership, even though this claim is denying there's membership in that region, and there's membership in this region, even though the claim is saying that there's no membership in that region, right? So A and E claims can both be false at the same, cannot both be true at the same time, can both be false. And then the final relationship that appears is what's called subcontrarieties, and it's the opposite of what goes on between the A and the E claim. And the A and the, this is when two claims are subcontraries, meaning they can both be true at the same time. They just can't both be false at the same time. So let me scroll up to the other document here, right? So here's our I claim. There's an X here. And here's a O claim. There's an X here. Well, is it possible that there could both be an X in this circle section and an X in both? Yes. So they can both be true, such that there is an X here and there is an X there. They can both be true. Can they both be false? No. Right? Let's go back to here. Because either there's an X in this section or there's an X in that section. Right? Again, on the presumption of existential import, right? On the assumption that the subject class has membership, it's got to be somewhere. So it's either here in the middle or it's here on the left-hand side, but they can't both So these cannot both be false. There's got to be at least one S, right? And that S either is a P or it's not a P. So just to review, contradictions cannot both be true at the same time and cannot both be false at the same time. Contraries cannot both be true at the same time, but can both be false at the same time. And subcontraries can both be true at the same time, cannot both be false at the same time. And then implication A implies I means if A is true, I has to be true. And if I is false, A has to be false. Likewise, if E is true, O must be true. But if O is false, E must be false. And so I lay it out there in the notes, and you can review that. But notice it's easier to move around the hypothetical square because there's lots more roads, right? So let's say I know that the A claim is true. Well, then I know that the I claim is true. I know that the E claim is false, and I know that the O claim is false. I know what all the other values are if I know the A claim is true. Why? Because I have all these roads that I can get easily from one corner to another corner pretty easily, right? Let's say I know that the O claim is true. Well, then I know the A claim must be false because it's a contradictory. And I know that the I claim must be false, and therefore I know that the E claim must be true. So it's kind of easy to make your way around the hypothetical square of opposition. I also want you to understand what these relationships are. All right, did this one, distribution, right? Distribution is an odd sort of characteristic. It's not really that odd. You read the notes, you can get your head around it. But when we are using rules to test for validity, it will be very important to know whether a term in a claim is distributed or not, right? And again, I leave the notes for you to figure out what distributed is. I won't take your time up here because you can read it on your own. But the pertinent thing is that in an A claim, the subject is distributed. It tells us something about each and every member of the subject class. That's what distribution means. In an E claim, both the subject and the predicate is distributed because I know something about each and every S, it's not a P, and I know something about each and every P, it's not an S. In an I claim, nothing is distributed because I don't even know something about each and every S, I only know something about one particular S. Likewise, I don't know something about each and every P, so neither term is distributed. It's a little hard to get your head around why this is the case, but in an O claim, the predicate, the P, is distributed. Not the subject, but the predicate. Again, read the notes if you want to figure out why that is, but in the end, you definitely want to remember it. A claim, subject, yes, predicate, no. E claim, both, subject and predicate. I claim, neither, subject, predicate, and O claim, not the subject, but yes, the predicate. And if nothing else, that makes it much more symmetric, right? So you've got yes, yes, no, no, and here you've got no, yes, no, yes. That's not why it's that way, but that's how it works out, okay? Here I talk about certain other logical relationships, right? Transitivity, symmetry, reflexivity, and equivalence. Right? And those are, I think they're useful relationships for you to know, but I'm not going to go over them with you here. I don't think it's necessary. I'll just finish off with this sort of thing, right? The fallacy of regarding a contrary term as if it were a contradictory term, right? So it's related to this notion of contradiction and contrariety, being a contradiction and being a contrary. They're related, they're similar in a certain respect, but they are distinct. So notice, were I to say no rocks are alive, therefore it follows that all rocks are dead. No, not really. Why is that? Well, because alive and dead are contrary terms. Nothing can't both be alive and dead at the same time, so they're contrary. But strictly speaking, they're not contradictory terms. The contradiction of alive would be lifeless, right? So anything which is alive is not lifeless, and anything which is lifeless is not alive. Those are genuinely mutually exclusive classes, and they are contradictories, right? Contradictions. So if I know it's lifeless, I know it's not alive. And if I know it's alive, I know it's not lifeless. But it's not the case that anything which is not alive is dead. I don't think rocks are dead, because dead seems to imply that it was once alive and it's not alive now. And rocks were never alive. So it seems incorrect, not it seems, I think it is incorrect, to describe rocks as dead. Again, the idea here is that alive and dead are contrary concepts, and something can't be both. But something could be neither, like a rock. It's neither alive nor dead, right? So we have to be careful about that, because we mustn't mistake a contrary term for a contradictory term. So for instance, if I said, you must have hope, otherwise you will fall into despair, right? Well, that is what I wanted to say, but it's not the best example. It's not a terrible example. But notice, is it the case that if you don't have hope, you are thus despairing? I think hope and despair are contrary concepts. You can't hope and despair at the same time. But it seems to me it might be neutral, right? Neither hoping nor despairing, right? And so you don't have hope, but you don't have despair either. My dog Louie neither hopes nor despair. Well, sometimes he hopes, that I'll drop food on the floor, I suppose, right? But even when he's not hoping, I wouldn't say he's despairing, right? Rocks don't despair, right? They don't have hope, but they're not despairing. So there could be being hopeful and being without hope. But again, I don't think that's the same thing as despair, right? So that would be another example of contrary concepts rather than contradictory concepts, right? All right, so that kind of concludes my remarks. Hope this recording turned out better than the first two. I hope you found it helpful. Naturally, if you have any questions, please let me know. And thank you for your attention. Until next time.